Welcome to qnawire.
Problem 11.15, we have this boom here. It's holding up a 5,000 Newton load. There's this guy wire. Center of mass of the boom is 35% along its length. So the center of mass will be roughly a third of the way up it. And what we want to know is first, what is the tension in this wire? And then what are the X and Y components of the force at the base here? So we have our equilibrium conditions that the torques have to add up to 0, and the forces in the X and Y directions, each respectively, have to add up to 0 because it's not moving, or it's not accelerating. It's not moving either, but it could be moving at a uniform speed and still the net forces would be 0. So what we want first is a free body diagram. So here's, let's say, our boom. We're going to want to compute torques around this point here at the base, because then we don't have to know what the forces are at the base, because their contribution to the torque about this point will be 0. So then the weight of the boom acts downwards here. Let's try and put that so it fits. So this is 0.35 L, this is 0.65 L. The weight of the load acts downwards at this end here. The tension in the guy wire acts to the left. We have an angle theta here that we know is 60 degrees. And then there are the X and Y components of the force we're interested in for part B. So, part A, the sum of the torques will help us find what the tension in the wire has to be. And we're, again, computing them using this point as our axis. So we have the tension times the length times the sine of the 60 degrees, because this angle is the same as that. These are parallel lines. This is a line going between them, so the angles on the alternating sides are equal. And then the weight of the load will act in the opposite direction, which, if this direction is positive rotations, this will be negative. This will be positive. And so that's times L cosine of 60 degrees. Make this the meter theta. The theta is 60 degrees, whatever. And then the weight of the boom itself, acting at 0.035 times L from the base. And this will also have a cosine of theta. And this has to add up to 0. If you solve this, and we know all of these things except for t, or we don't know what L is, but you can see that it cancels out of everything, so it doesn't matter. And so then we find that the tension is 3.41 times 10 to the third newtons. For B, so now all of the forces have to add up to 0 as well. So in the x direction, our x force minus the tension has to be 0. So the force in the x direction is exactly the same as the thing we just found. Y direction, we have a couple more things. Well, actually, we have one more thing. Not even a couple. So the force that this is exerting in the y direction minus the weight of the load minus the weight of the boom has to be 0. And so the y component of this force is 7,600 newtons.